Hi, I'm Allison Campbell from the Pacific Northwest National Laboratory. Today I want to explore scientific impact, and I want to talk about how we as scientists seek to do research that impacts the world around us. Today I'm in a firehouse, and I want to explore how research that we're doing at the laboratory helps our first responders and our soldiers perform at their operational readiness. And in particular, helps them to perform under the adverse environments for which they find themselves. Smoke, heat, chemical exposure, and fatigue are all things that face our first responders and our soldiers, and they are things that can affect, ultimately, their performance on the job. So tell me a little bit about the science that you do.
Well, I would say that we're very inspired by what we've learned in the environmental health field over the last decade, about some of the opportunities that the field brings us for improving the health of, for example, the first responder population in our country. And I think a really good demonstration of that, it comes from, in some ways, a tragedy, is something we learned in the time of the Gulf War back in the 90s. It happened that we would take very well-trained soldiers, so they were fit as a fiddle, passed all their medical exams, they were strong and well-trained, and they went into the theater, and during their time, they were exposed to all the stresses of the war. So that's some social stresses, the trauma that goes with fighting a war, and all the chemical exposures that they came in contact with. Fatigue is another great one. Yeah. And what happened was the experience of those two people is very different. One got sick with Gulf syndrome, war syndrome, and the other did not. And so the big question is, why was there the difference between the experience of these two people in terms of their health? And we know something about that now. It turns out that there's a genetic basis for that difference. And so we've learned that there's an intersection between genetics and a person's environment, the stressors they're exposed to, that influences whether they're sensitive or resistant to that environment. Really right now the scientific challenge is understanding disease mechanisms and how chemical exposures and other stressors actually influence those disease mechanisms. So as a laboratory, we have a long history of understanding chemical exposures, where chemicals go in the body, and how they interact with parts of our body and actually deliver or drive these mechanisms of disease.
So we're talking about molecules moving around and communicating and signatures and signaling and all those sorts of things. And that's what we're trying to look for.
That's right. So historically, a big strength of the laboratory has been in the measurement capabilities. And so with that capability to measure biomolecules, lipids and proteins, and to combine that with genetic information and what we know about exposure, we have some real opportunities here to help identify the exposures that are problematic, help identify the people that maybe will be more susceptible to those exposures, and then design mitigation strategies. Maybe that's better equipment, or maybe it's physiological and chemical sensors that allow us to know when they're starting to drift into a range where they're actually suffering from specific damage, right? A good example of that is that the Army is very interested in the challenges, the physiological problems that arise in warfighters that go and operate in very difficult environments. Special operations, for example, and they're finding that when they go into these environments and they change their food, right, and they have no sleep and large amounts of physical activity, all of a sudden they have gut challenges, right? And those gut challenges translate to even more fatigue and loss of operational effectiveness and their overall health. So the Army is very interested in trying to solve that very practical solution by understanding more about the human microbiome and the interaction with fatigue and food.
So how are we going to explore that going forward as a laboratory? So
this is kind of an exciting time because the laboratory has just decided to fund what really is a partnership between EBSD and the National Security Directorate. They funded an agile investment to actually tackle some of these challenging problems. And as a part of that effort, we're going to be working with the U.S. Air Force down at Wright-Patterson Air Force Base. They have a force health protection unit that takes this topic of trying to understand how human genetics influences the impacts, our susceptibility and resilience on exposure very seriously. And so we're going to be partnering with them to help bring some of our laboratory capabilities to that particular problem and kind of develop some new capabilities at the laboratory to help in that space. We have now a new Air Force Research Fellow, Major Sherrod Brown, who's at the laboratory to kind of carry on some of the efforts that our last one, Major Alfie Felipe, started. So yes, he's going to be one of the key people working between AFRL and our group here at the
So
laboratory.
that's another example of bringing the end user on site, working side by side with us and giving us the perspective of the, the application of the science we do.
And it's probably worth mentioning that as part of that relationship with NSD, many people know Luke Gossink, and he's been with Grant TG up in Seattle, been working with the Department of Homeland Security developing some sensors, physiological sensors. And actually, he's got a great idea to work locally here with the first responder population and InnovaWorks in a partnership to kind of help us look at sensors and physiological status for some real-time feedback.
Yeah, that's great. I feel like in this way we're having sort of a primary and secondary impact in that we're really helping those that are keeping us safe. And by keeping them safe and sound and at their optimum performance, they're going to help keep us safe and sound. And so you really, it's while it's a first responder or a soldier, it ripples out into the entire community, the work that we're doing.
I agree, the benefits will be felt potentially across the whole community.
Justin's part of a large team that's been working on this for a long time. And in fact, their research, their teaming effort is helping other teams operate at peak performance and peak readiness. And in fact, it goes way beyond that. It's really helping these individuals be healthy, active, and prepared in both their professional lives as well as their personal lives.